Science words for the day. This one is quantum with a capital Q. So the word quantum, when used by some people, rationalizes woo, justifies woo, sells woo, because quantum is one of those words in physics, if that's where you're bringing it from, that has a pretty specific meaning. So what is a quantum? When you talk about a quantum in particle physics, specifically, you're speaking to an audience of particle physicists. My frame for the word quantum is it is the sum of the studies of individual particles. Now, that word sum of the studies, or that term sum of the studies, we still are not highly confident in our ability to see individual particles. This is the world of CERN right now. Remember, we can see elements. We can see that periodic table of elements, and we can see some of the isotopes around those elements that exist. Underneath that, beyond that element, beyond the physical boundary of what we know about, are particle physics. And particle physics we know a lot about, but not enough. So we have to use things like quantums. A quantum is a number of discrete events. It's the analysis of a number of discrete events. So now you can say if I had 50 of these discrete events and 49 of them had the same result, I'm still not sure what that means. But I know I got 49 out of 50. I know I got it by using two different detectors and discrete particles emitted from a common element, and 49 out of 50 are seen by one detector, and that other different detector sees number 50. Now I have a quantum. But a quantum in physics, that thing we're trying to measure, the quantum is a measurement technique. Through the study, you're going to define the characteristics, or you might learn the characteristics of that one particle, but the 49 out of 50 matter the most. But that one still might have you curious. But really, we are seeing this with our mind's eye. And by mind's eye, I mean the detector that saw this, 1 out of 50 out of a 10 million emissions from that, whatever the action was, whatever burnt, whatever vaporized, whatever changed phase, whatever disintegrated, right? So quantums, in chemistry, you don't use quantums, you use moles. You typically use moles. And moles, a mole is a specific number of atoms that can be elements, or it can be elements. So you can have 10 moles of H2O, or you can have 10 moles of H, and you can have 10 moles of O, and that won't make 20 moles of H2O. So chemistry thinks more in moles. Physics, particle physics, are thinking in these quantums. because in these quantums, when you measure enough, you begin to create hard correlations between enough. And now enough becomes quantifiable. Enough has an error margin around it. So my Geiger counter has a 30% error margin around any reading it is showing you. It's built into the detector itself, no matter how it's shielded. If it's shielded on top of that, it changes. So that's actually some quantum stuff, measurements that we're doing. So we're a little bit beyond chemistry, yet chemistry is still writing the top rules. When I come out of the an atomic level conversation, I crossed a boundary. I'm on the other side of a wall into a different atmosphere, but the other side of the wall still exists. It did not disappear. It's not in my mind. So I'm over 6 minutes, twice as long as I wanted it. But quantum, the word, like the word evolution, like the word God, like the word wall, can and many times do have a context in a quantum layer. Get that? Does that make it any easier? Is that a piece help? Thanks. I really wanted this to be 3.